All right, welcome back. We are now getting into section 12.2, so measures of central tendency. Now, you've probably heard of these terms before, but if you're a little rusty, hopefully this will refresh your memory. So when looking at a set of numbers or values, it is sometimes useful to identify a number that the others seem to cluster around. This middle number is called a measure of central tendency. Now we have different types of these, but the first one is probably the most common one, and it's the mean. The most common measure of central tendency is the mean or average of the values. It is calculated by adding up all the values and dividing by the total number of values in the set. Now, as much as that seems to make sense and you understand it verbally, what kind of formula can you create from that? And that's one of the problems with math, is we like to have a formula for anything that we're doing, if possible. So how we can create a formula is first by defining some terms, some symbols. So if x represents a set of values, then the notation, this funky looking E, is actually a Greek symbol, and it's the Greek letter sigma, and specifically it's a capital sigma. So usually when people see that symbol, the word that should pop into your head is sum, because you're going to be adding things up. So this symbol, sigma x, represents the sum of those values. So we're adding up x. So let's look at an example. So if x was representing the set of values 1, 4, 3, 8, 7, and 1, then sigma x is just the sum of those. So we're adding each of those values up, and in this case we get 24. So now for the mean, we have another symbol. It's x with a line over the top of it, which is also called x bar. So to denote this mean of those set of values, so in our example, x bar should equal 24, which was the sum, divided by 6, because there's 6 numbers in here, 1, 2, 3, 4, 5, 6. So if we divide by 6, we do get 4. So 4 is the average of those numbers. So this is the formula for finding the mean. But if you just understand what the process is, that's all that matters. Now we will see some of these symbols later on in the next section, but for now, it's not the end of the world if you don't use them or write them down. But here's our formula. So x bar equals sigma x all over n. So let's find some means. So for finding the mean of these numbers, we can see that there's 5 of them, so we should be able to determine that the mean is going to equal something divided by 5. So let's add those up real quick. So 3 plus 7 better be 10, plus 12, plus 16, plus 23. So I get 61. So if we put 61 over 5 and divide those, let's divide that by 5, and we get 12.2. Now, as far as decimal places, in general, there is a rule of thumb to follow for rounding when you're finding the mean. It's all based off of your data, though. So in this case, our data were all whole numbers. So there's no decimal places. So when we find the mean, though, we like to have a little bit more accuracy. So we should extend the number of decimal places by 1. So in this case, since there was no decimal points here, we want to make sure we have 1 decimal point minimum in our mean. Now over here, we can see that all of our values have 1 decimal point. So the mean, we extend that. And so we should be able to have 2 decimal points for our mean. If it happens, let's see what the math tells us though. So we first want to add those up. So let's do that real quick. So we got 3.1 plus 4.5 plus 6.2. Whoops. Helps if I type the right numbers, Lee. 3.1 plus 4.5 plus 6.2 plus 7.1 plus 4.5 plus 3.8 plus 6.2 plus 6.3 equals 41.7. So 41.7 over, we got 1, 2, 3, 4, 5, 6, 7, 8 numbers. So if we divide that by 8, we get a big crazy decimal, 5.2125. Now, we don't need all of those decimal points because our data only has 1. So minimum, we should use 2. Now we can use more if you want to be really technical, but minimum though would be 2. So in this case, we'll round it to 5.21. Now, one of the things you should have hopefully noticed in our example here was that we had some repetition in those data values. So there was a 3.1, let's see, there's a 4.5 that happened twice. There's a 6.2 that happened twice. So sometimes we're going to see that where the values repeat themselves. So when those things happen, when those repetitions happen, do we have other ways to find the mean? And the answer is yes. So can we simplify finding the mean if we had frequencies that were higher? So let's take a look and see how we can do that. So you can see we have a nice sorted list of data. We got 4 1s here, we got some 2s, we got some 3s and 4s and 5s and 6. So how can we find the mean a little differently than adding them one at a time in our calculator? Nobody wants to do that. So here's the trick. Instead of adding them one at a time, let's multiply by how many there are. So we have the number 1, but we have 4 of those. So with one operation, we can take care of all the 1s. But remember, we want to find the sum. So that just takes care of all the 1s. So we need to add that to all the 2s. So we have the number 2, but we have 3 of those. And we can keep going. We got 2 3s. We got 4 4s. And we got 2 5s. And we even have 1 6. Now it might seem silly to want to multiply it by 1, but for now let's write it this way, where we can multiply it by 1. So if we did all of that math, we multiply first, add second, that should give us the sum of all of our data. Now if you wanted to do that, you could. Some people like to just keep going with something that they understand. So let's multiply all those together first. And we can see that this should give us 48. Now, if you're not sure if you did it right, you can always go back and add them one at a time. If you add those one at a time, you should get 48. But this is just another way to get that sum. Now, how about the bottom? We can do it a couple of different ways. One way would be just to count them one at a time. I have 1, 2, 3, 4, 5, and so on. But is there another way? And the answer is yes. Let's take a look at what we multiplied by. We said that there was 4 1s and 3 2s and 2 3s, 4 4s, 2 5s, and 1 6. If we take all those repetitions and put them into the bottom, and then add those together, that should be the total number of values in our data set. So if you add those all up, we end up getting 16. And so if we divide, we do get 3. Now remember, the whole point of finding the mean is that your answer should be somewhere in the middle of your data. So if you're doing something wrong, if you're dividing by the wrong number and you get a weird answer and it's not in the middle, then you better go back and see what you did wrong. So in this case though, 3 does look like it's in the middle of this data set. You know, we didn't check up here, but 12.2 does look like it's in the middle of this data set. 5.21, again, the smallest one was 3.1. The largest looks like 7.1 here. So between 3 and 7. Well, 5 is between 3 and 7, so this is probably right. Now, that's just a kind of a look to see if it makes sense and it's the right answer. But as long as you're following the process, you should be fine. So let's try this method of multiplying on a different problem. Now, if we wanted to, we could put this into a formula. So the formula is going to look something like this. Looks pretty messy, but we're going to walk through it. So, but first, by adding the product of each value and its frequency and dividing by the sum of the frequencies, we obtain the weighted mean. So that term weighted just means that there's repetition in some of those values. So it has a larger weight to it. It contributes more to the sum because of that repetition. So if we wanted to do the formula, we could just put all of what we did in words into mathematical symbols. So we want to add the product. So x times f. X is the value, f is the repetition, the frequency. So we had to multiply to get those products first, and then we wanted to add second. So remember that E symbol means we're adding. So we're adding those products, but then we wanted to divide by the sum of the frequencies. We have to add the frequencies. So again, there's that addition symbol, add the frequencies. So it looks funky, I'm sure, but once you get the understanding of how those symbols work, it does make sense. So let's try it now. We have a different setup. We have a frequency distribution, and we want to find that mean. So one of the things you could do is say, I don't want to use that formula. I want to do it the other way. So the other way would involve you doing this. First, you have to deconstruct your table. So you'd say, okay, well, I have the value 25 and I have 4 of those. So I could say, okay, well, I got 25, 25, 25, and 25. So there's my 25s. Now I have to list my 28s. I got 7 of those. And you can see the problem, hopefully, is that you're going to be writing a long time just to get the list all generated. And you can see that we've got a lot of repetition going on. We got 15 of these 32s we'd have to write out. And I don't think you want to do that. And neither do I. So instead, let's do what the process says. First, we want to multiply. So we need to do that x times f. So there's our x's, there's our f's. So if we multiply across, we get 100 there. If we multiply that, looks like 196. Multiply those, you get 300, 93, 32 times 15, I believe is 480. And so there's our products. So we've taken care of those batches of numbers really fast with just a single operation for each of those. So now we have to get the sum. So let's add those up. 100 plus 196 plus 300 plus 93 plus 480 equals 1169. So 1169 is the sum of our values, and now we need to divide by, be careful, don't be tempted to say that there's 5 numbers, because there's not. There's a lot more than that. You have to add those frequencies. So what do we got? We got 11, 21, 21 and 3 is 24, 24 and 15 looks like 39. So 39. And so now, if we divide by 39, we get 29.9743 and change. Now, as far as rounding this, again, you want to be careful what you round it to. We should at least go 1 decimal place because our data didn't have any. But when we go to 1 decimal place, that 7 is going to bounce that 9 up to a 10, which bounces this up. So in this case, we could get away with saying this is equal to 30 or 30.0. And that would be fine. And does 30 look like it's the middle of our data? You bet. Remember, our values range from 25 to 32, so 30 is definitely in between. So we're probably good with that answer. All right, so that takes care of finding the mean. We're going to see some other measures of central tendency in the next video, so stay tuned for that.